Good morning, one and all. This is Dr. Diana Moses. Welcome to session 12 on modern software engineering. And we have been looking into some of the agile concepts on planning agile projects. As we already know that agile processes are more parallel and chaotic in nature, the planning aspect of agile development is quite difficult. So we have formed certain principles that can help us plan effectively in agile environments. We have been looking into how vision can be set for a project and how a plan can be released and how to monitor risks, how to manage risks, how to foresee and mitigate risks. On all that we have seen already. And we also know that in extreme programming and agile methods, the way of delivering a software is through iterations. So every XP project runs on an iteration of 1 or 2 weeks each, and each of these iterations have some deliverables to deliver to the client. And each of these iteration will have a plan, design, and a development and a testing phase completed with the done criteria. So all of this management has been looked into the iteration planning, and now we will discuss about what a slack is. A slack is something that you introduce into every iteration so that you achieve your iteration commitments. Like, for example, every time we plan for an iteration, we have a commitment of completing some story with the done criteria. Now, when a story is taken up for development during a particular iteration, by the end of the iteration, we are committed to deliver the complete aspect of the story. But is it possible every time to set up to keep up our iteration commitment? It is not practically possible to keep up this iteration commitment. So Slack is a type of agile practice in extreme programming, and it is essential for planning for a successful sprint that yields consistent and high quality results. Slack assists in delivering consistent sprint commitments and high quality software. This mainly concentrates on delivering on our iteration commitments. But how do we deliver our iteration commitments? Imagine that the power cable for your workstation is just barely long enough to reach the wall receptacle. Then you can plug it in if you stretch it a little bit, but the slightest vibration of it will cause the plug to pop up out of the wall and go out of power. Now you lose everything you were working on, and you can't afford to have your computer losing power at the slightest provocation. The same situation you can imagine for your development. Now your work is too important. In this situation, you would move your computer a little closer to avoid those few bumps. Then you can tape your cord to the floor so that people don't trip over or your power supply doesn't get interrupted. Your project plans are also like these. They are vulnerable for disruption. So you plan for certain movement in your project that help you to stay safe during development. Just like how you move your computer towards the power socket and have it so that nobody trips over or you don't lose your power supply. The same way in your development also, when you identify that there are certain things where you'll have to make the ends meet, instead of trying to make them meet, you make provisions so that you get the ends closer to each other so that you are able to deliver your iteration commitments. Now this can be thought of as a buffer that can give you some time gaps in between your iteration so that you can accomplish your iteration commitment. Now in such scenarios, how much slack should we introduce? The amount of slack that you need doesn't depend on the number of problems you face. It depends on the randomness of these problems. If you always experience exactly 20 hours of problems in each iteration, your velocity will automatically compensate. However, if you experience between 20 and 30 hours of problem in each iteration, your velocity will bounce up and down. So you need 10 hours of slack to stabilize your velocity and to ensure that you will meet your commitments. So as long as you are having a latency of the same time period continuously, your velocity of production code delivery is going to be the same. Whereas if you have a variation in the number of work hours or the latency hours, then you might have to introduce some slack into every iteration so that the velocity of delivery of production code remains the same. How do we introduce this slack time, or how do we introduce this buffer time in the iteration? One way to introduce slack into your iterations might be to schedule no work on the last day or two of your iteration and plan only for 5 days of work and leave the last 2 days remaining free, so that every time you have some increased latency, you'll be able to catch up in the free hours and then still deliver your iteration commitments. But this would give you a slack, but it would be pretty wasteful. A better approach is to schedule useful, important work that isn't time critical work, but if you can set aside in case of an emergency. Now, one of these methods is called as paying down technical debts. That fits the bill perfectly. Now, when we introduce the slack, we always know that our code will have some technical debts. Even the best teams inadvertently accumulate technical debts. Although you should always make your code as clean as you can, some technical debts will slip by unnoticed. So every iteration, you look for some opportunities to make the existing code better. Paying down technical debts directly increases the team's productivity. As you fix on some of the technical debts, focus on fixes that make your current work easier. So you add or you refactor your code after every iteration so that your code performs better, and it also pays off your technical debts during your iteration itself. So introducing time for paying off will be a better way to introduce the slack into your iteration. And the other way of introducing a slack time is to introduce something called as a research time. Dedicate some research time to each of your individual in the project. It's an excellent way to encourage learning and to add additional slack into your iterations. It is to set aside half a day for each programmer to conduct some self-directed research on a topic of their choice, but be completely hands-off. Leave them free for that half day so that they'll completely concentrate on their research, and you'll be able to introduce slack during that time. So when your iteration commitment is at risk, so if you're unable to deliver in your iteration commitment, what you do is you omit these two aspects. If your iteration commitments are at risk, it's okay to set these two tasks aside temporarily in order to meet those commitments. The tasks that you can set aside are paying down your technical debts and the research time. Use refactoring also as a shock absorber. Before starting a big refactoring to pay down technical debt, consider the iteration plan and think about the kinds of problems that the team has encountered. If the iteration is going on smoothly, go ahead and then refactor. So when your iteration commitment is at risk, incur a little voluntary overtime from your own teammates. Be careful not to overuse your overtime. Overuse will sap the team members' ability to do good work. You can use it to clean up after small problems, but each programmer should only contribute an hour or so at the maximum per day, and they should do it voluntarily. And there are two major problems that actually cause change in velocity, or there are two major sources of randomness in XP teams. These are the customer unavailability and technical debts. So if you reduce these two, you might have to reduce your need for introduction of slack itself. So both of these they lead to an unpredictable environment, making estimation very difficult, and they also required you to have more slack in order to meet your commitments. So if you can directly tackle the customer unavailability and technical debts problem, then probably you'll be able to overcome introduction of slack, or you will need less of slack time in your iterations. Now, these are some of the key takeaway points from the slack concept. Slack is an essential in planning for a successful sprint that yields consistent and high quality results. Slack is more like a buffer that is vital to protecting critical deadlines such that a project can proceed smoothly. There are two major sources of randomness in XP teams: customer unavailability and technical depths. These two are the reasons that cause a change in velocity of delivery of your production code. If you are unable to change these, introduce slack. The two major methodologies to introduce slack are paying technical debts, and two is the research time. Thank you for listening. We will meet in the next session. This is Dr. Diana signing off.